Hi, boys and girls. Good to see you. Today's Tuesday, and we're going to take a look at our DMA for today. There's one problem that we are going to introduce some information to you, and then that's the first problem. So let's take a look at our first problem for our DMA today. It says, about how much water will a bucket hold? Now, we are looking at measuring water here. Okay, so water is a liquid. And when we measure water, we are looking at not the length, because inches would be measuring the length of something. So we're not measuring the length of the water. It's possible that we could be measuring the pounds, but really weight is usually measuring solid objects. So weight, we usually measure using pounds. Now, if the water was in, let's say, ice form, we might be able to measure the water as pounds. So that leaves us with two other options here. Now, liters and ounces both can measure liquids. So I'm going to show you what the difference between liters is compared to ounces. So I have a coffee cup here, if you notice, and this coffee cup is about 8 ounces. So 5 ounces would not even fill this coffee cup, if that makes sense to you. So think about that. Would we use these 5 ounces right here to fill a bucket? Okay, now let's take a look at what a liter is. And this is very close to a liter of water. So this water bottle is close to a liter. It's not quite a liter, but it's pretty close. So think about it. If I were to take 5 of these water bottles, would this be more likely to fill a bucket than less than this coffee cup? So if you chose 5 liters, that would be an accurate estimate. Estimate meaning about how much, right? Because we see the word about here. About means not exactly, but close to, right? Close to. So the word about means close to that amount. So we know that it's going to be about 5 liters if we wanted to fill a bucket. All right, let's take a look at our addition sentence here. And we want to take this part and this part, and we want to put them together to make a whole amount. So we have 2 parts that we want to put together to make a whole. So I would like to start us off with using breaking it apart into place values. So I'm going to take my 100 and my 800. So this is 100 and this is 800. And I'm going to take those and I'm going to add them together. And 800 and 100 is 900. Now what I'm going to do is I'm going to take the 10 and the 50. So I'm going to take this 10 and I'm going to add it to 50 from the 853, and I'm going to add them together. So 10 and 50 is 60. Now I'm going to take my ones and I'm going to take this 8 and add 3. So notice I keep this in the ones place and I keep this in the ones place, and I have 8 plus 3, and together that makes 11. Notice I was able to make a new 10 from the 8 and a 3, which means I'm regrouping this 10 into the 10's place. So I have 1 from my ones, I have 60, and another 10 makes 70. And I don't have any hundreds that I'm regrouping, so I have 971. Now, if I use my algorithm, and I take this 853, and I add 118 to that, I'm still taking my two parts and adding them together. When I start to add these together, I'm going to start in my ones place. So 8 plus 3, we just said was 11. So I'm going to have the 1 stay in the ones place, and the 10 from the 11, it's going to be carried over to the tens place. So I have 1 10, 5 10, which is 50, and another 10, which makes 60. So 50 plus 110 is 60, plus another 10 is 70. That means I don't have enough tens to make a new 100, but now I can go to my hundreds place and add my 100. So I have 800 plus 100 is 900. So again, I still am getting a sum or total of 971. Now I have one other way that I can do this, and it's starting with the 853, and I can add on each place value a little bit at a time. So if I take the higher of the two add-ins, which is 853, and add 100, add that 100 from the 118, then I have 953. Now I can add 10 more to 953, so add 10 more, and I'm going to add that 10 here to the 50 to make 60, so now I'm at 963, and then I can add on 8 to the 963, and if I add on 8, I can add on 7, which would make this a new 10, which would be 970, and then one more. Oh, sorry, 7, not 6. 7 and 1 makes 8. So I'm adding 7 more to make the 970, plus 1 more is 971. All right, now for your discussion today, I want you to write a subtraction sentence that you could use to check this, okay? Again, I want you to take and write a subtraction sentence that you could use to check this, all right? Be interested to see what we get, and then we'll go over it tomorrow in our DMA for today, which would be Thursday. So the next problem is looking at equivalent fractions. So it's asking us, are these two fractions equivalent? Well, let's go ahead and write the fractions next to the two squares. So this square is broken up into 3 equal pieces. That's my denominator. There's 3 parts in the whole, one whole square, and one of those pieces is shaded. Okay, one of the parts. So this is 1/3. Now, if I use and look at this square, we're using this shaded amount and comparing it to this shaded amount. Do they look the same? Now look closely. So let's take a look at, I have 1, 2, 3, 4, 5, 6 equal parts. And 3 of those parts are shaded. So that means I have 3/6. So I'm going to use my fraction strips to kind of model this. So the first square said we have 1/3. So again, remember we're comparing this to the whole. So we know that 1/3 is only one of the 3 pieces in a whole, 1/3. Now it told us to compare this to 3/6. Now if you remember, it takes 2/6 to make an equivalent fraction to 1/3. So if I take and add another 1/6 here, what does that tell us? Well, we know that 2/6 is 1/3. And 3/6, does anybody remember what 3/6 is in simplest form? If you said 1/2, you would be correct. So 3/6 is actually a half. So when we go to look at comparing this 1/3 to 3/6, we're actually saying that this is half. And we know that half is going to be a greater fraction than third, because when you break something up into two equal parts, those halves are going to be greater than the thirds. So now I can write a statement that says 1/3 is less than 3/6, or 1/3 is less than, I could also say half, because half is what we're comparing it to, because that's in simplest form. So no, these fractions are not equivalent, because 1/3 is going to be less than 3/6. And we can use that to describe. So if you notice that if I were to take this piece right here and this piece right here and turn them to the side, this would fit right in here nice, and this piece right here would fit in very nicely here, and then I would have my 2/6 equivalent to my 1/3. And this piece would actually be right here in that section there. So you can see that this is a little bit longer and goes halfway down to the middle of my square. So this is why it's going to be considered half. All right, let's take a look at our rounding problem. This is another skill that we've been working on for quite a while. We want to round to the nearest 100. So I'm underlining my hundreds place here. When I round to the closest 100, I want to look at my hundreds place to decide if I'm going to stay at this 100 or I'm going to round up to the next one. So 153, I have 100, which is in my hundreds place, or I can round it to 200, which is the next 100. So I'm either going to stay at 100 or I'm going to round up to 200. Now remember what's in the middle of 100. What's halfway between 100 and 200? If you said 150, you would be correct. 50s are always the middle when we're rounding to the closest 100. So if it's less than 100, we're going to round down to 100. If it's greater than 50, we're going to round up to 200. So let's look at our tens place. We have 53. So 153 would be right about there. Actually, it might be really much closer than that. Maybe right there, right? It's going to be really close to 150. But since it's past 150, we know that we are going to round up to the next 100, which is 200. Now, we can use these same 200s to round 117, because 117 is between 100 and the next 100, which is 200. Now, 117 would be right over here somewhere maybe, right? We're estimating. But we know that it's going to be less than 150. And anything that's less than 50 in the tens place tells us that we are going to round down. So we're going to round to 100, but not up to 200. So now when I take the 200 and add it to the 100, this is going to be about 300. Now let's make sure and look for the exact sum. So I'm going to use my algorithm and line up my place values, and I'm going to add. So 7 plus 3 more makes a 10. So that means I have a 10 to regroup here. 50 plus 10 is 60, and another 10 would be 70. So 7 tens, and then I don't have enough tends to make a new 100. So I'm just going to add these hundreds that I have, which is 100 and 100, makes 200, and that's 270. Now, if I look at 300 compared to 270, these are fairly close to each other. And if I were going to round 270 to the closest 100, I would round it to 300. Now remember, when we're rounding to the closest 100, that's going to be a little further or different than if I were rounding to the closest 10. If I rounded to the closest 10, this would be 150, and this would be 120, and these would actually be exactly the same. It just so happens that the estimate is really close to the actual exact sum. So remember that if the closer you're rounding to that place value, the closer it's going to be in the difference between the two exact and the estimate. All right, that's it for today. Don't forget to go back and give me a subtraction sentence that you would use to check your addition sentence. And I will see you guys during whole group today. Bye. See you soon.